In this video, we're going to introduce another logical operator called the Sheffer stroke. So we have P Sheffer stroke Q, which I'm going to call P up Q, and that's to be read as P NAND Q. So this is P not and Q. So it's equivalent to not P and Q, which is the same thing as saying not P or not Q. So first, I want to provide the truth table for P up Q and the truth table for P up P. So first we'll do the truth table for P up Q. And we want to take a look at what this looks like so we can find some logical equivalences. So I'm going to do two truth tables just so I don't have unnecessary rows in the second. So possible combinations for P is 1, 1, 0, 0. Q is going to be 1, 0, 1, 0. So this is true when either not P or not Q is true. So in the first row, P is true, Q is true, so P up Q will be false. In the second, third, and fourth row, at least one of them is false, so these are all true. And we can see this is the equivalent of not P and Q, because if we have P and Q, then our truth table would look like 1, 0, 0, 0. So P up Q is just the negation of P and Q. Okay, so let's do the truth table for P up P. So if P is a 1, P can also be a 0. So if P is 1, then we're going to have 1 up 1, and that is going to be false. But if P is false, then we have false up false, and that's going to be true. So what do we see here? We see that P up P is equivalent to not P. So this is going to be pretty useful to know. So here's what we're saying here. If we want some well-formed formula phi, and we want the negation of it, this is the same thing as taking phi and combining the two with the Sheffer stroke. So this is important for the next question. Okay? So using the Sheffer stroke, I want to provide a definition for P and Q. So here's what we know. We know that P up Q is equivalent to not P and Q. Okay? So P and Q is the same thing as saying not P and Q. So this is kind of like saying, okay, we want the negation of P up Q. So because we did that very simple truth table with P up P, we know how to define the negation. So we just take this not phi equivalent to phi up phi, we just substitute phi as P up Q. And if we do that, then we can get the formula for not P up Q. So this is equivalent to P up Q up P up Q. So because we know our method of changing the negation into the Sheffer stroke, we can change this negation into the Sheffer stroke by taking P up Q and upping it with itself. So that is how you use the Sheffer stroke to provide a definition for P and Q. Here's a quick one. Do this very quickly and then I'll do it with you. We want to find a definition for P or Q. Okay, so try this on your own, and I'll do this right now. Okay, so P or Q. What is this similar to saying? So this is similar to saying not P or not Q. Okay, we both agree with this. And then we can take out a negation. So this is like saying not P and not Q. Okay, so this is pretty similar to not P and Q, which is the definition of the Sheffer stroke. So what we need to do is we need to define this not P in terms of the Sheffer stroke and this not Q in terms of the Sheffer stroke. Okay, so we know how to do that. We know that not P is the same thing as P up P. And we know that not Q is the same thing as Q up Q. So this not and is the Sheffer stroke itself. So our definition of P or Q is just P up Q up Q. Okay, so that was OR. So hopefully you got that right. If not, you can leave some comments down below with your questions. And if you have any other questions, please leave them in the comments below, and I'll answer them as best as I can.